Okay, so we basically have three things we need to talk about today. Variables, constants, and number systems. What's a variable?
Number? Oh, change, something changes, right?
A variable is something that changes, that's correct. Conversely, what's a constant?
It stays the same.
It's something that stays the same. Okay, so let's look at the sheet I passed out here. Let T be the temperature in Fahrenheit. So is temperature something that changes?
Yeah.
Yes, so that would be a variable. What does T equal negative 10 mean in this situation? Temperature is negative 10 degrees. Nothing too fancy there. Temperature is negative 10 degrees Fahrenheit. Part B. Let T be the number of years since 2011. What would T equal 5 mean in this situation?
5 years since 2001.
And when is 2 years? When is 5 years since 2011? 2016. So T equals 5 means the year 2016. Okay. Question number 2. A rectangle has an area of 36 square feet. Let W be the width, L be the length, and A be the area of the rectangle. Give the dimensions of 3 possible rectangles having an area of 36 square feet. So how could a rectangle have an area of 36 square feet? How big could the rectangle be?
9 by 4.
9 by 4. So it would be, width would be 9 feet, length would be 4 feet, and area would be 36 square feet. So there's one possible answer.
6 by 6.
Could be 6 by 6. Width could be 6 feet, length could be 6 feet, and area would still be 36 square feet. Okay, then it asks for 3, so we need one more.
3 by 12.
3 by 12. Width could be 3 feet, length could be 12 feet, area would be 36 square feet. Of the symbols W, L, and A, which ones are variables? Length and width are variables. Why are length and width variables? They change. Is area a variable in this problem? No. How come area, even though we gave it a letter, it stays the same? So area, that would answer part C. Area is the constant. So which are variables? W and L. They can change. And which is a constant? A. It is always 36 square feet. So just because something has a letter doesn't always mean that it's a variable. In this case, A is a constant. It's always 36. Oops. Yeah. Oops, if you can see what I wrote. Questions on that? Okay, so that's variables and constants. The next thing we need to talk about are number systems. All right, so we have lots of different types of numbers. Can anybody tell me what the counting numbers are? Well, if I asked you to count, how would you count? 1, 2, 3, 4, 5. Those are the counting numbers. So the counting numbers are 1, 2, 3, 4, 5. ... means it goes on forever. Okay, so those are the counting numbers. How about integers? Anybody know what integers are?
Whole numbers.
Well, okay, whole numbers would be the 1, 2, 3, 4, 5, and then we throw in the number 0. Those would be whole numbers, but integers is even more than that.
Fractions?
Nope, not fractions. the negative ones. So we're going to have, integers are usually written this way, dot, 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 -4, -3, -2, -1, 0, 1, 2, 3, 4, dot, dot, dot. So those are the integers. So it's all those nice numbers that you like, 1, 2, 3, 4, 5. We throw in 0, and then we throw in the negatives of those two, -1, -2, -3. All right. Somebody already gave the answer to this one, but they might not have known it was the right answer. Anybody know what rational numbers are? Those are fractions. So the word rational comes from ratio, and ratio means fractions. So these are fractions of integers. With one little condition, the bottom cannot be the number 0. So give me some examples of some rational numbers. 3 over 9. Which of course we would reduce to 1/3. Give me another rational number. 3/4. How about -8/5? Is that a rational number? Yeah, it's a ratio of integers. How about 7?
Could be, right?
It could be. I could write it as 7 over 1. I could write it as 14 over 2. So all the nice numbers that we like, all those integers, all the integers also happen to be rational numbers. Now, here's some trick questions. Maybe not trick, maybe you know the answer. What's 3/4 written as a decimal?
0.75.
0.75. What's 1/3 written as a decimal?
0.33.
0.33, and it goes forever. So rational numbers can be written as fractions. Rational numbers can also be written as decimals. But what has to happen for the decimals? They have to stop, or they have to repeat, like 0.33333 going forever. So rational numbers can also be written as decimals that terminate or repeat. And my examples were 3/4 is 0.75. That's one that terminates. That one ends. And 1/3 is 0.333. You can either go dot, 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 or sometimes we go 0.3 with a bar over the top. That one's one that repeats. All right, so that takes us to the opposite of rational numbers. The opposite of rational is irrational. What would irrational numbers be? Well, if rationals are decimals that stop or repeat, then what's irrational? They don't stop and they don't repeat. So these are decimals that don't stop and don't repeat. Can you give me some examples? Pi is probably the most famous one. Pi is about 3.14159. It's actually 2.6. It's 2.65, but calculators almost always round it off to 7.
Yeah.
And then it keeps going. There's no pattern to it. It doesn't repeat. It doesn't stop. It goes forever. That's as far as I know, by the way. 2.65. Yeah, there are some people who have memorized it to hundreds of thousands of places. It's crazy. Some people just. But that's pi is probably the most famous one. Anybody know any other irrational numbers? Square root of 2 is another decimal that goes on forever. Square root of 3. How about square root of 4?
No.
No, that one stops, isn't it? Square root of 4 is a nice number. It's 2. All right, but none of those are really very nice, I don't think. Here's an irrational number. 0.12. 112. 1112. 4 ones and a 2. 5 ones and a 2. ... That's an irrational number. Does it end? No, it doesn't end because I put ... Is it repeating? No, how come it's not repeating? It does have a pattern, but what's the pattern? I add one extra 1 every time. What's that?
What is that number?
What's that number?
Yeah.
That's a number that I just made up. But it's not irrational. It's an irrational number. But I like it better than pi because it's one that you can see. It clearly has a pattern. You can understand that number, but it doesn't repeat because every time you repeat, every time you go to the next block, you add an extra 1. So I don't know I don't know that there's any special name for that number. I just made it up. That's a nice irrational number. Other questions?
Would infinity fall into that one?
Infinity is not a number.
All the numbers, yeah.
It's a quantity of all. Right? It's not a number.
I was just sure it never stops.
It doesn't stop. That's true. So it's not a number. All right. So the last question is on this sheet. I've given you a list of numbers. The numbers I've given you are negative 4.6, negative 2, 0, square root of 3, 5 halves, 3, pi, and 250. Of those numbers that I've listed there, I want to know which ones are the counting numbers. What were the counting numbers again? 1, 2, 3, 4, 5. So which of those numbers fits into 1, 2, 3, 4, 5?
0, 3, 250.
0 doesn't work, does it?
Oh, no.
Because when we start counting, we start at 1.
Right, right.
3 and 2.
There's no 6.
There's no 6. That's a 4. That's negative 4.6.
3 and 250.
3 and 250 are the only ones that fit into that. That's correct. Okay, how about the integers? Now remember, integers was 1, 2, 3, 4, 5. Plus we threw in 0. Plus we threw in negative 1, negative 2, negative 3, so on and so forth. So which of those numbers that I listed fits into those?
Negative 2, 0, 3, and 250.
Negative 2, 0, 3,
250.
and 250.
Now, why would the negative 4.6 be?
Because negative 4.6 is a decimal. Once you have decimals, what numbers are those?
Rational.
That would be a rational number. Negative 4.6 is rational. All right. Well, the next one's pretty easy. Which ones are negative numbers?
Negative 4.6, negative 2.
Negative 4.6 and negative 2. All right, and then it asks for rational numbers. Now remember, rational numbers were fractions, or they were decimals that stopped or repeated. What do you got for rational numbers?
5 over 2.
5 over 2. That's a
Negative 4.6.
Negative 4.6.
negative 4.6. There's more of them.
Negative 2, 0, 3, 250.
Negative 2. Negative 2 is a fraction, isn't it? Negative 2 over 1. There's a sneaky one. You forget about those. 0 is a fraction. 0 over 1. 3 and 250. So there are lots of rational numbers in that list. But that's an easy one to forget. When people think of rational, they'll usually get the fraction, they'll usually get the decimal, they'll forget about the other integers. All the integers are also rational numbers because they are fractions. Okay, now we're looking for the irrational numbers. Well, those would be the only ones left.
Square root of 3 and pi.
Square root of 3 and pi. And I didn't talk about real numbers before, but what are real numbers?
0, 1, 2.
No?
Is that everything?
Everything. All numbers are real numbers. So if I ask you for real numbers, the answer is easy. All of them.
Are there actually imaginary numbers?
There are something called imaginary numbers. We will not talk about those in this class, but if you take Math 1215 next semester, we'll talk about imaginary numbers. Questions on any of that?